Alright, boys and girls, Mr. Giomini. Want to come to you a little video support for questions 14, 15, 16, and 17 on page 434 in your math workbook. It says here, which of these pyramids do you think has the greater surface area? Explain. Well, we have a square pyramid, and we have a triangular pyramid. The first thing to me is, I think, wait a minute, a square-based pyramid has a square base plus 4 triangular faces. So this has 5 faces. This is a triangular pyramid. All the faces are equilateral triangles. Now, I'm thinking this one here has 4 faces. Again, square-base pyramid, we have the square base. All right, and then we have those 4 triangles, each extending off of one of the edges, one of the sides of the triangle, or of the square, excuse me. All right, now we go to the triangular pyramid. All right, we have that triangular base. Okay, again, sorry for my sloppiness here. And then we have a triangular face, and again, these are all supposed to be congruent. Apologize, I know it's probably doesn't look exactly good, but this is not a precise drawing here. All right, and then we have those 3 triangles coming off. I'm just thinking 5 is greater than 4. But now it says here, let's take a look at the numbers of this. So the numbers I've only dealt with are the faces. The numbers of the problem, square base. So the base here is 10 by 10, and the height is 8.6. 8.6. Now it says here, all the faces equal to a triangle with a base of 10. So this is the base of 10 and a height of, so that means it's equilateral triangle. So these are all 10, and the height is 8.6. Well, the first thing I noticed is that the area of all these triangles and all these triangles will be equal because the dimensions are the same, 10 by 8.6. So we just think about the area of the triangle is 1/2 base, which in this situation is 10, times the height of the triangular face, which is 8.6. Well, 10 times 8.6 gives us 86. Half of 86 gives us 43. That means that every single face on here is 43. And it's the same of all the triangular faces here. 43, 43, 43, and 43. So right now, the areas are, or the surface areas are equivalent. They're equal. But we have to remember this has a square base. Taking into account that that's a 10 by 10, that would give me 100. That makes this surface area 100 square centimeters larger than this one here. All right? Let's take a look at question 15. Take a look at question 15 here. Let's go to the next slide. There we are. Okay, question 15 and 16 I have here. It says here, let me get this out of the way. It says the base of a pyramid can be any polygon. Any polygon. How many faces does a pentagonal pyramid have? Now, pentagon. I think about a pentagon, I think about it in Washington, D.C., that's where the Defense Department is headquartered. A pentagon has 5 sides. All right? Some people like to think of this as almost looking as a house, if you would. All right? We have that pentagon. All right? Now, if I have a pentagon, now the thing is that this pentagon is a little bit different because we have these right angles here. So really my pentagon is going to be kind of tough to create a pentagonal pyramid in that format. So I want to make my pentagon so that all the angles are, I want to rent a regular pentagon so that all the angles are congruent. So let's see if I can draw this myself. Actually, you know what? I think I might have a pentagon option right here. Let's take a look. There we go. So there is my pentagon, all right, my pentagonal pyramid. So the base is a pentagon. 1, 2, 3, 4, 5. All right, excellent. Now, if we think about this, it's a pentagonal pyramid. So the base is a pentagon. Now, that's just the base. I have to have a triangle coming off each one of those bases. Let's see if I can do this here. Can I make a triangle? Let's see here. Now I'm going to rotate this. So if this is a pentagonal pyramid, each of these triangles, there we go, the bases must all fit like that. Because again, it's going to be a little, let's see here. Stretch it, there we go. So again, if I think about this, and let's just change the color. So we're going to have these coming off of each of those. All right. So we'd have 1, 2, 3, 4, 5, 6. So we'd have 6 faces. We'd have 6 faces. All right. If I want to type this answer out, probably change the color too so we can see it better. There we go. There are 6 faces on a pentagonal pyramid. All right, now I'm going to move my drawings out of the way here. All right, let's go back to my, oh, no, I don't want to go back there. There we go. Come on. Technical difficulties here. There we go. All right. Come on. There are 6 faces on a pentagonal pyramid. 5 of those faces are triangles, and 1 is a pentagon. All right, straightforward. Next one, what is the term used to describe a point where 3 or more edges of a solid figure meet? There we go. All right, now, if I were to draw a 3-dimensional shape, let's just draw something very easy. Let's draw a cube. All right, there's my cube. We have a square because the cube is just constructed of multiple squares, faces. So if I think about this, we're going to go 1. All right. There's there. Here. 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 There. Okay, there is my cube. Now it says, what is the term used to describe a point where 3 or more edges of a solid figure meet? Well, we have 3 or 4 edges meeting right there, right here, right here, right here, in the back, here, here, and here. We call that a vertex. We call that a vertex. So, if I were to type this answer out or write it in your book, we want to rephrase the question or answer. The point where 3 or more edges of a solid figure meet is called a vertex. All right? Makes sense? I'm going to clean all this stuff off here because when I go to the next slide, it'll carry all this with us, and we don't need all this nonsense for that. Yeah, there you go, see? Delete, delete. All right, next one. Next question. Question 17. Which net represents the pyramid with the greatest surface area? Now, for this question, we need to think about this. We can do a couple different things here. We could try to find the surface area of every single face if we'd like. All right. We could do something like that. All right. Now, what they've done here is they've kind of given me the fractional parts here, which is nice. Okay. Now, first thing I think of here, which net represents the greatest? Now, if I look at this one here, and I'm just comparing the ones that they've given me the dimensions, they're both triangular pyramids. This one has a larger base than this one. It has a greater height than this one. So right now, I definitely know it's not going to be C because B has the greater surface area. Now, these two are both square-based pyramids. But again, looking, the square here has a base of 1, 2, and 3. This has a base of 1, 2, 3, and 4. So already I see that this base is larger than this. The height of this triangle is, this face is 1, 2, and 3. The height of this one is 1, 2, 3, and 4. So I can already see the height of this one is larger. All right, so I know it's not A. So what I'm really doing is comparing B and C. Same thought process, what we went through the one earlier today is, let's take a look. This has a square base. This has a total of 5 faces. It has a total of 4 faces. Let's find the area of this face here. It's 1/2, right? base, which is 5, times 4 and 3300ths. And we're going to take all that and multiply it by 4. Let's cheat here, use a calculator. Expedite this process. We go. I know a half of 5 is 2 and 5/10, or 2 and a half. 2.5 times 4 and 3300ths equals 10 and 825 thousandths. That's the area of one of these faces, but there's 4 of them, so we'll times that by 4. That gives us something along the lines of 10 times 11. We'll round out about 44. We got 43. So 43 and 3/10 square units. All right, so let's go units square. Now I come over here. We have a 1, 2, 3, 4. 1, 2, 3, 4. We have a 4 by 4. The area of this face here alone is 16. We have a 1, 2, 3, 4, a height of 1, 2, 3, 4. 4 times 4 is 16. Half of 16 is 8. We have 8, 8, 8, and 8. There's my 5 faces. I go 4 times 8 gives me 32. 32 plus the area of the base gives me 16. I have an area here of 48 square units. Which one is greater? Well, 43 and 3/10 is less than 48 square units. All right, hope this helps. I hope everybody's doing well. Take care, guys. Sorry about all the technical glitches there. All right, that's my fault. Still learning every day. Take care.